So this is week 4, and week 3, checking around. We're doing series and parallel circuit in the lab. So kind of coincide with what we are learning in the other class. It's just a practical part of it that helps you understand and see this in action. So we did the lab yesterday, Monday, and people saw how actually series and parallel circuit take place. And I did the resume board, so I have to do it again. It's okay. And let's go over it. So series circuit, we said it's done for safety, control, and there's only one path. It consumes more power. Why? So what happens to the resistance?
Less.
No,
It
it goes up.
increases. Resistance goes up.
Resistance
When
goes
it's
up.
hot, right?
Yeah. One path only, and it's very simple, one after the other. So I'm going to draw this here. Okay, so we said it's safety, control. This is what it looks like. Three. Okay, and what happens to voltage?
It drops.
What happens to voltage? It drops. Current
Stays the same.
stays the same.
Yep.
Resistance.
Add them all up.
Yep.
Oh, I saw the equation yesterday for adding resistors in parallel.
Yeah.
And it's 1 over RT.
Yeah.
Yeah. That's why.
We'll go over it. So voltage will drop, which means V total will equal V1 plus V2 plus V3. And what is V1 and V2 and V3? When you go over each one of those distances, you will find different voltage. So it will be the same. A total equal A1 equal A2. So the current, if you clip here, it's going to be the same as if you clip here or if you clip here. Resistance, R total will equal R1 plus R2 plus R3. Good?
Yeah.
So, in the lab, I want you to draw the schematic, so when you go to the lab, it will make things easier, because it gets confusing when you go and try to wire things. So, what we have is the line voltage, L1, neutral, coming down. It's going to go through the switches. Neutral go all the way down. So we have fuse here, breaker, switch, we have firematic, then we have another switch. Okay, so now I have 3 light bulbs in series. So the hot line is going to go through them all, one after the other. So it will connect here. This is not neutral anymore. It's going to be also a hot line. Hot line will go from the first one to the second one, from the third one to the last one, and then you will have a neutral. So this is the confusing part, right? The hot will go from the first one and comes out of the first one, goes to the second one, and so on. So this is in series. Sketch this down on a piece of paper. So in the lab when you go, it will make life easier. This is in series. What happens if you take one light bulb out?
They all go.
They all go. If one of them burn,
They all burn.
they all go. And if I measure the resistance for each one of them and add all of them, so the total resistance will be the addition of all individual ones. And the voltage here will drop. You'll see the voltage here is going to be different than the voltage here and the voltage here. And if I take the voltage from here to here, it's going to be 120. So I want this to be the condition we have in the lab. Any question about that? I know it looks easy on the board, but when you go there and try to test it, it's going to look a little bit different. So make sure sketch this on a piece of paper and take it with you. Make things easy. So this is the series circuit. This is what it looks like. Again, things looks differently on paper. When you go there, it gets a little bit confusing. So try to follow the schematic. Draw this, and these are the switches in series. It's what happens. The resistance and current is the same thing we talked about before. It's over there. So I is referred to the current. They call it I, call it A. Some people can call it C. It's the same thing. So the total is equal, the same, and resistance is equal to the addition to all of them. Good. The voltage is going to be the total voltage. So the voltage will go to each one of them until completely depleted. Questions about series circuit?
Was that word in the middle next to in series?
Yeah,
No, what's that word like?
Oh, firomatic.
paramedic. Is it too small? What's a paramedic switch?
Isn't it the shut off?
Yeah, what, when? Yeah, how hot? If there's a fire, it will melt and break. And what is the temperature usually? I think it's 165 degrees. So it will melt and shut off the circuit, which makes sense if you have a fire. If it's too hot, it will shut off completely, and it represents safety. So this is a series circuit. Parallel circuit, more than one path. It's good for redundancy. It has lower load on the circuit. So I'll do the parallel here. This is what it looks like. Line voltage. And R1, R2, R3. What happened to the voltage?
The voltage will stay the same.
Stay the same. Meaning V total equal V1 equal V2 equal V3. 1, 2, and 3. Current,
Will divide.
yes, it will split. So A total equal A1 plus A2 plus A3. Resistance,
It'll decrease.
yes. Will decrease. And to find the resistance, and usually I'll say that so you can remember. R total equal, actually, smaller than the smallest resistance. In the circuit. Okay? So, I did not cover this, so I'll cover it tomorrow. This is how we find our total. This is a simple way to do it. I'll start with the same thing as series. I'll do something I call flip, which means 1 over RT equal 1 over R1 plus 1 over R2 plus 1 over R3. This is flipping, because everything is divided by 1. So I'm going to flip everything. Take a step, flip everything. Then I'll do divide. I'm going to, so this will remain the same. I'll get a number over here. So divide 1 over 3 or 4 is going to give you a number, right? So I'm going to get a number here, plus another number here, plus another number. The idea is to get rid of the fraction, get a number, a decimal. Make things a little bit easier. Then I'm going to add. This will remain the same. These 3 numbers are going to be 1 number. You agree? Finally, I flip again, because I'm not looking for 1 over R. I'm looking for R. So I will flip and I will get RT will equal 1 over whatever number I got. It will be a very small number. So these tips you can write down on a card and bring with you to the quiz. I'm going to leave them on the board here. I don't care about how you do it. It's getting to the number. If you find out, most people mess up this step. They add the numbers and say, hey, this is our total, which is not the truth. The truth is 1 over this number, and it should be the smaller than the smallest one in the circle. If you follow these tips, it should make things much easier. If you look at the book, there's a lot of division and multiplication that's very complicated. This, just write down the steps, do it 1 by 1, carry it through, it should give you the right number. I will do a few examples tomorrow.
Okay.
We'll practice together.
Yes.
It's not going to be very complicated. And I'll stick to three resistances. Okay, what would it look like in the board when we do the wiring today, Wednesday, and Friday? And we did it yesterday. So Monday class was the pioneers. So I have my switches again. L1 neutral. I have my fuse. Switch. Firematic. Switch. Okay. 3 light bulbs. So, what do we say for parallel circuit? What happens to the current?
Is this thing?
Yeah, but
Splits up.
it's gonna split, right? So from the hot line here, I'm gonna have 1 going to the first one, second one, and third one. So if you notice here, this is the A total. This is A1, A3, A2, A3, and if you follow the current, it's going to split, goes all the way here, and split again, and this is going to be A2, and so on. What about the neutral? Same thing. sketch that out, put it in your paper, so when we go in the shop in half an hour, we can replicate that.
So this one is series and that one's parallel?
Yes.
Is there another
Series.
one?
And if we notice, if we take the total resistance from here to here, you'll find it's way much less than the resistances in each one of those light bulbs. What do you think? Doable?
I think so.
Yeah.
Fahad, you said we're going to the lab today?
No, you did that yesterday already.
Oh,
You did well. You remember?
no.
Yeah. So it was good.
Yeah.
And you will notice a few things here. If you take one light bulb out, it's going to shut the entire circuit because there is no continuity. And you will notice also the light here is very dim. Some of them might not even like light up because they're not getting enough voltage. Over here you see that all of the light bulbs are bright. And if you take one out, the circuit is still going. And this is a very simple exercise to know the difference between parallel and series. And if you're trying to diagnose an AC, the AC has loads connected in parallel. The compressor, the fan, the control, they're in parallel. Controls you come first, but you have fan, you have thermostat, and you have the compressor. The fan might be on, but the compressor is off, or the heater is off. So they are wired in parallel. So just because one of them is off, or the system is on, does not mean that it is running. This is what it looks like. It looks like a ladder. It is the heater, compressor, fan, light bulb. So those four are in parallel. If you eliminate one of them, the system will still run. They get power. And also it's good for reducing the load. It's less resistance, which is very helpful. What happens to the current? It adds up. You add 3 of them. And this is the resistance. It gets smaller, 1 over RT. We know this calculation here. I'm going to have to do some practices over that for the next class. But if you follow the steps one by one, just don't skip any of them. It's going to be there. Put it in a card, flip, divide, add, flip. You should be fine. Just don't skip it. Don't try to like have a shortcut. It should be fine. Always remember the last step. And also, you're going to verify if the resistance is bigger than the smallest one. You did something off. And if you can manage that, we're done with the math for this class. Simple. Voltage is going to be the same. So each one of these equipment will have enough voltage. Here is again the analogy between water and circuit. If we were to think of the water flow as the current, you're pumping the water, that's your voltage. Small resistance, small flow. It's big resistance actually, not small resistance. It's very big because it's pushing it down. It's gonna be small flow. Same thing as here. If you cut the circuit, you're gonna have a leak in here. And if you cut the circuit here, you might have a shortcut.
Okay. It is the same thing.
Yeah, it's not going to go around. You might have ground created. So always try to use this kind of analogy between water and circuit. In the circuit to run through it, you don't want the water to go in the house, right? You want the water to go in the circuit, coming inside the house, going into the sewer. That's a complete circuit. And over here, well, the second one like that, that's the same as flow. This is the boards we're working with. Again, so far for this semester, we're going to cover only this part. This we'll do next semester. And I have one more electrical, actually 2 more electrical labs to do. Other than that, I'll do some kind of soldering and cutting. But I want to cover this first because this is going to coincide with the material we're doing in theory and control. So at least you can see some kind of theory and see how this will work in practicality. And usually, this will make things stick a little bit. Schematics, everybody get the schematic down? I don't want to go to the lab and tell me, oh, I'm confused, I don't know what I'm looking at. This is how it's gonna be. Danny, don't look at me. Write it down. Huh? Okay. Take a picture, write it down. So this is how it's going to connect in the lab. And I believe in something called productive struggle. If you struggle a little bit, it will stick more.
Yeah.
So give it some time. It's not supposed to be really easy. So schematic is here. Everybody did it yesterday successfully in less than an hour. So it wasn't really that bad. So we can do it again. And this is the picture. In series, in parallel, follow the picture. This is the simplest way. At some point you will have to follow complicated schematic. And we're gonna build up step by step. We're gonna follow the schematics. You'll go to install mini split or central air. We're gonna give you some really heavy schematic with a lot of wire coming in and out, and you have to be able to look and find the source, trace those wires, and yeah, it's what you signed up for. Don't blame me. Okay? These are the switches, light bulbs. Make sure you have good connection, make sure you check your switches, the wire is loose, and so on. The use of the meter. So, bless you. Again, I did say how important it is to know how to use the meter. You're gonna measure resistance, you put it in the ohm, you're going to measure voltage, and you're gonna measure, and let's look at this meter. Who bought a meter?
Well, not the pen, like an actual.
Yeah.
No.
If you bought a meter, it's good to bring it so you can practice how to use it. Most likely, all the new meters have all the functions you need to know. And repetition helps things stick. So this is our meter. How do we measure amperage?
Put it out, man.
We clip it around one.
Bless you.
I'm gonna use this. I'm not gonna use this. It's like-
Big ass light.
You were here yesterday? You were here yesterday?
Yeah.
I'm gonna use a small light bulb. I think this is a joke or something.
Did you see the video of the 10,000 watt light bulb?
No, probably this is it.
Oh my goodness. It's ridiculous.
That was the broken one.
Yeah.
Yeah.
We'll use the huge one. Whoa, too bright. Okay, so if I want to measure the average, I'm gonna turn the equipment has to be on. If it's off, so first of all, I'm gonna set it on amps. It's gonna be around 2 amps. If I clip it on one wire while it's off, I see 0. Turn it on, 2.16 ohms. See the clip it? And if I clip it on both, what should I get? 0. Okay. How do I measure voltage? You're gonna set it on voltage. What does the squiggly line mean?
Approximately. Or AC.
AC. The blue line, the straight line is DC. So I'm gonna put it in. Let's go. 115. Measure voltage, I measured amperage. How do I measure resistance? It's the omega. And I have to touch it to the 2 terminals. So this is 5. Hold on, let's touch it. .9 ohms, and it's going to keep changing. So what I want actually to stress as well is if we were to measure the resistance of a light bulb when it's off, is it going to be realistic?
Yes, because it's off.
Yeah, but when you turn it on, it's gonna change, right?
Yeah.
What happens to the resistance when the heat increases?
The voltage increases.
What about the resistance?
It'll increase.
No, it stays the same, doesn't it?
No.
Oh, it goes up.
It goes up. And this light bulbs produce a lot of heat. It's gonna be so hot you cannot touch it. So you can see the resistance increases and increases until it's stabilized. So that's why it's really hard to predict.
Because to try to basically
Yeah.
resist
Yeah.
the heat.
Yeah. So what we do is to find the resistance of a light bulb is we're using Ohm's law.
Yeah.
The power is always written on the light bulb. They tell you it's 15 watts, 7.5 watts. That's when it stabilizes. And we have the voltage is 120 volts, so we can estimate how much is the resistance. This is one way to know what is the resistance of a light bulb. Same thing with motors. If they're running, you can't really estimate the resistance. It's going to be different when it's cold than when it's running. And the other thing we just can measure as is when the system is wired. So this is hot, this is actually cold now, so probably going to give you a different reading. So, and I will show you a little heat, a little bit. And measure and show you how it drops.
Pretty sure it's not a safe idea if it gets that hot.
I'm watching it. Okay, it's very hot right now. So I turn it off and measure right away and show you how it's going to keep dropping.
Will that drop?
See how it's 2.8? When it was cold, it was 5. So as it cools off now, it's going to increase the resistance. See? It increases, changes with temperature. 3, 4, and so on. So that's why it's not reliable to measure the resistance of equipment when they're hot or when they're cold. You have to have them running and optimized and stable to run. Okay, so you might also see this in the field. These are all variations of ohm and power law. However, if you know those two triangles, it's a combination of all these things. I personally do not like to carry this with me because there's square roots and confusing things.
Can I take a picture of this?
Huh?
Can I take a picture of that?
Yeah, you can. But if you know those two triangles, that's all you need. It's just variation shortcuts for you not to use them together. And this also you can find online. So let's say you want to find the voltage and you only have the power and resistance, is what you do. Otherwise, you're gonna go and find the amperage and voltage using Ohm's law. I personally, you can do whatever you want, but I personally prefer to have the two triangles, remember them, and take the extra step. But you also can use this formula. Okay, so that's all I have for this lab for this week.